Hello and welcome back. Today we'll be talking about speed and velocity. A lot of people are confused by this, but speed is not the same thing as velocity. Speed is actually a scalar value. That means it has no direction, meaning 55 miles an hour is speed and a scalar. There's no direction attached to that. You don't know what direction you're going 55 miles an hour. However, if you were to say, I'm going 55 miles an hour north, that's velocity, because velocity is a vector, because it has both the scalar value of speed and a direction. Let's look at some equations. In order to calculate average speed, you'll be taking total distance traveled over time. Average velocity is similar, but it's actually displacement over time. A more common way of seeing average velocity is like this. This top value is displacement, this bottom value is change in time, and you'll notice that there is a little line above the V. This line means average. Now, average velocity is helpful, but what if I wanted to know the velocity at any given time? This isn't exactly accurate. In that case, we get to use calculus. Instantaneous velocity can be described as the derivative of displacement in terms of time. This allows us to calculate velocity at any given time, given we know a displacement function. Now, integrals are the opposite of derivatives, and so if we are given velocity, we can find displacement as the integral of that velocity function in terms of t. These are both extremely crucial concepts to understand for kinematics, and once we start introducing graphs, we'll definitely come back to these. Let's try an example. Let's say there's an object that took 20 seconds to go this path, 2 meters to the right, 1 meter up, and 2 meters to the right again. How would we calculate average velocity? Well, the first thing we're going to have to do is calculate displacement. The initial point is here, and the final point is here. So, making a vector between these two, and treating the initial point as 0, 0, you get the vector 4, 1 as displacement. Now, the equation V average equals displacement over change in time uses the scalar version of delta S, which means we're going to have to take the magnitude of the vector. 4 squared plus 1 squared square rooted equals root 17, which simplifies into 4.1. Now we have both displacement and time. Calculating V average is simple now, because we can take the displacement, 4.1 meters, over the change in time, 20 seconds, and get 0.34 meters per second as this object's average velocity. Let's move to a little trickier example. Let's say we have a position function defined in terms of time as cosine t. Can you find the speed at t equals pi over 2? From first glance, this might seem almost impossible, but there is a very quick and easy way to solve this. We can define velocity as the derivative in terms of time of position, which in this case is cosine t. The derivative of cosine t is negative sine t. Now all we have to do is plug in pi over 2 into our velocity equation. So negative sine of pi over 2 gives us our answer of -1 meters per second. Let me quickly point out that this is actually velocity and not speed. And I know this because speed cannot be negative. Thank you for watching, and I hope this was informative. Happy learning!